Good evening, and welcome to another episode of Maths in an Empty Classroom with me, Mr. Southern. This evening we're looking at sketching Lund graphs. And before we talk about Lund graphs, we're just going to revisit e to the x, the exponential function. Incidentally, if you haven't already watched the videos on sketching exponential curves, you should really do that first, because I'm going to be talking throughout this lesson about the relationship between e to the x and Lund of x. So I've sketched on this diagram in black the graph y equals e to the x, which, as we know, intersects the y-axis at the point 0, 1, because if x is 0, e is a number, any number to the power of 0 is 1. We also know that as this graph continues its journey here, it is never going to reach the x-axis, because you are never going to be able to get a number to a power equaling 0. We have an asymptote here, y equals 0 for e to the x. Now, we know that ln x, natural logarithm, log to the base e, is the inverse of e to the x. So it does the opposite function. And when we were solving exponential equations, we were using the function ln to do the opposite of e. So the fact that it does the opposite, rather than having the point 0, 1, we have the point 1, 0, because that x and y coordinate have switched around. Which is what happens with inverse functions. You might be familiar with from GCSE with the notation f of x for a function of x and f inverse x for the inverse function. So it's very much like if you square, the inverse is to square root. If you sine, the inverse is to inverse sine, shift sine, arc sine, whatever you will. Now, the relationship between these two graphs is they are actually symmetrical in the line y equals x. So that line I've just drawn in there is the line of symmetry. Ln of 1 is 0, that's why we've got this point here. And if you think about the relationship between the two graphs, if we have y equals 0 as an asymptote for e to the x, we're going to get x equals 0 as an asymptote for ln of x. So you cannot ln 0, just like you can't log 0. If you do a number to a power, you can't get 0. That means we can't put 0 in here, and therefore we have that asymptote, x equals 0. And just like with all graphs, when I look at transformations of this function in the next video, we're going to be looking for those three key things, which is the shape, the intercept, and the asymptote. And if we have those three things correct, it is impossible to draw the graph incorrectly, and that isn't a challenge, that's a statement. I'll go through a specific example in the next video. I'll see you then.